we've got our anti-cafe Greco simulation model built. And the challenge now is to run it to see if any debugging is necessary. I've probably built about maybe 10 models now in AnyLogic, and it's becoming a little easier to build them without too many errors. But no idea if we're going to get something until we actually run it, and then we'll try and just go through the debugging process together. Then I'll show you a couple of strategies to validate. So let's just go ahead and run it. And it does show us an error. So let's just go ahead and hit proceed. It's usually some typo, or but let's just see what it feeds us. Okay, so an exception occurred. Sees, okay, so you can see I've got a typo here. Sees a server. So I'll clean that up. So I believe it's here. I've got the problem. Excuse me, it's just wherever I've referenced C server. So let's try again. It's actually good that we had at least one error. Just so you can observe it in action. Okay, we've got another error. The agent has not been through a corresponding time measure start object. So that has got something to do with the timer. And let's just have a look at that. So timer start is there and timer end. And I wonder what the issue here is. I think what's happened here is that this is not actually connected. Now it's connected, all right? So the lines, for some reason, it didn't quite get into the line. It was just like, hanging in space there. An easy mistake to make. So let's now try it again. Okay, so it's running now. So I want to run this one to completion, and then we're going to validate the result. So this is an MG1 model, and I want to just stop it before we do that, and I need to add one or two more pieces to this. So stop that. And I want to go in here and limit the model to having a maximum of 50,000 arrivals. And the reason for that is there is a limitation on the free version of the 50,000. So let's go ahead and save that up. And then I'm also going to have an associated time limitation. So each inter-arrival takes 60 divided by 38 minutes. So less than 2 minutes, but I'm going to multiply that number 60 divided by 38 times 50,000, and according to my calculator, that should be around 78,950. So I'm going to just stop this simulation at 78,500 minutes. Okay, so let's run it. And I'm going to go ahead and click on this little gear sort of thing, click on these three dots, and I just put in 78,500. Again, the number that I'm looking at there is, it's the 50,000, which is, the maximum number of arrivals times however many minutes, which is 60 divided by 30. Because there are 38 per hour, so it's 30 and 68 minutes, and that is approximately equal to 78,947. So I'm going to just go in a little short of that, and then we can go ahead and run this thing. So you can see it seems to be moving along. We are getting some estimates of the waiting time. The utilization is currently at 54%, but it's just starting up, and I'm going to speed this up just so we can observe how it's going. So let's run it about 25 times. So the waiting time is now increasing. Utilization is going up to 72, 73, so forth. So we're expecting the utilization to be in general, our formula for utilization is rho is equal to lambda over K mu. And so in this particular setup, it's going to be 38 over, and then there's one server time divided, so times 40. And this is equal to 95%. So I'm really expecting to see this number creep up. It's at 91 now. And now I'm going to, run it all the way to completion. I probably need to move the graph. You can see the utilization is laid out here and there as well. And it's actually 86% utilized. Not quite sure why these time averages differ, but I think this is the more believable one. And then I need to check the box on this one. So I've just learned that I've got a little bit of work to do. I need to slide this graph over so we can read this number. And then I also need to put the mean in. The mean is 10 or 11 here. But let's run this to completion just so we have our first estimate. So you can see I've run 50,000 now. Oh, what happened there was I didn't press enter. When you put a function in the 78,500, you do need to hit enter. So I'm going to just back up on that, and I'm going to move this around just a tad. The other thing was that I need to check the box for mean on this. Right. Okay, so let me run it again. Still in debugging mode, really. Well, validation, I guess. It's still cleaning up the model. So again, let's set this up. But now I want to actually hit enter, 78,500. So hit enter so that it appears in red here. And then let's run it to completion. Okay, so the estimate of the utilization is 94.1%, 7.78 in the line, and a waiting time average of 1385. Now let's go back into the case and then just use the calculators. So we're going to use the GGK calculator to get a queuing estimate of what the performance will look like. And we just do run all here. Just make sure everything executes. You need to have a little green check mark here or some indication that it's completed processing. And then you'll get your widgets and we can complete this. All right, so the arrival rate is 38. And then the service mean is 90 seconds. So that implies a service rate of 40 seconds. For a Poisson process, the coefficient of variation, well, the squared coefficient of variation will be 1. There's one server. And then this one is a little tricky. I'll just lay out the calculation here. So it will be, just get my pen going again. So CVP squared is going to be the standard deviation over the mean. And then square that. And so it's going to be 20 over, what is this, 90? All squared. And according to my calculation, this comes in at 0.049383. So I'm going to plug that value in. And so 0.049383. Okay, and then you're getting your estimate. So that utilization agrees with our prior analysis. The average number in the line should be, in fact, 947. Our simulation result was somewhere in the 7s, but you should run multiple runs to investigate what's going on there. And get a better estimate. And then our estimate of the waiting time is 0.2492. So if I run that through the calculator, 0.2492 times 60 is 14.9 seconds, which we're a little short of. To get a second run, what we would do is just go in here and go to our projects. Go to the, let's see, it's simulation main, and then change the seed value here to just any other number, say 2. Essentially just kick off the random number generators at some other point, and you're going to get a different run and a different estimate. So I'm going to run this one so that you can observe, and then we'll cut over, and we probably need to debug one more case. We'll run it with 3 servers, but I'm going to just try running this one more time, just to observe if I do get different results. So it was, let's see, it was 76,500 that I want to stop it at. Hit enter so you get it in red, and then we can just zip through this. Okay, so this one is 93.5%, 93.5%. 14.37 now, as opposed to 14.95 estimate using queuing theory. And the Q length here is closer. It's 8.121 versus 9.47. So I would do 3 runs. There's going to be a little bit of slippage using simulation versus queuing, but the numbers are relatively close. Okay, so let's end this clip, and then we will look at one more debugging, and then I will walk through how to set up the various scenarios here.